Question number 5. Subdivision A. The cumulative frequency diagram shows information about the distance traveled by each of 80 motorists in a month. So the graph is between distance and the CF. Use the cumulative frequency diagram to find an estimate for subdivision A, median. So how to get median? N is equal to, that is the total motorists, N is equal to 80. So median will be 80 by 2, which is 40th value. It is not 40, it is 40th value. So find the 40th position in the CF axis and then drop it down on the x-axis. So this point where it meets the x-axis, that reading is the median. So which is nothing but 1480 kilometer. Then subdivision B, interquartile range, interquartile range, which is Q3 minus Q1. So what is Q3? Q3 is equal to 3 by 4 of 80, which is nothing but 60th value. 60th value. Let's complete this Q1 also. Q1 is equal to 1/4 of 80, which is 20th value. Now we'll go back to the graph. We'll figure out which is the 60th value. So draw a line from the y-axis, touch the graph, and then from that point come down to the x-axis. So it is 1600. So this is Q3. This is the median. Q1. Q1 is the 20th value. And come down, same way, touch the graph and come down to the x-axis. So this is 1160. So difference between these two, Q3 minus Q1, is 440, which is equal to 440 kilometer. Oh, already kilometer is given. Subdivision 2. One of these motorists is picked at random. Find the probability that this motorist travels more than 1800 kilometers. So we have to find out the motorist who is traveling more than 1800 kilometers. So now this time we will find 1800 in the x-axis and draw a perpendicular to the graph, and then at that point look for the y. So this point is 72, 72, 74, 76, 78, 80. This is 72, which means what? Above this mark, 1800 mark, there are 80 minus 72 motorists, which is 8 in number. So probability will be equal to 8 by Total motorists are 80. So 8 by 80, which is equal to 1 by 10. You can write 1 by 10 or 0.1. Section B, subdivision B. The distance around a racing track is 5.104 kilometer. The time taken by a car to complete one lap of the track is 1 minute and 18 seconds. Calculate the average speed of the car. Give your answer in kilometer per hour. Okay, so speed is equal to distance by time. Distance is 5.104, which has been given in kilometer, but time is given in minutes and seconds. So let's convert that. So 1 minute is equal to 1 by 60 of an hour plus 18 seconds is equal to 18 divided by 3600 of an hour. So if we take the LCM, finally we will get 78 by 3600 hours. I am not simplifying it here. I am just going to take this value as it is in the denominator. So 78 by 3600 hours. So 5.104, this 3600 goes to the numerator by 78, which is equal to 235.5 kilometer per hour. Unit is already given. Subdivision C. So again a graph is given. X-axis is top speed given in kilometer per hour, and the y-axis, the frequency density is marked. Not the frequency, it is frequency density. Subdivision 1. Show that there are 8 cars with a top speed in the interval 120 to that 160. So now let's recollect the formula. Frequency density is equal to frequency by class width. So now for 120 to 160 in the graph, look at the graph. So let's mark this height. So this is 0.2, 0.1, 0.2, 3.4.5, right. So which is, now frequency density is 0.2 is equal to F divided by the class width. How to get the class width? 160 minus 120, which is 40. This is the class width by 40. That means F is equal to 0.2 times 40, which is 80, and a decimal point is there, so 8. So we proved, hence proved 8 cars, right. Subdivision 2. Calculate an estimate of the mean top speed. You must show all your working. So now let me take down the graph. So 120 to 160. 160 to 180, 180 to 200. So these are the groups given in the graph. So I'm just taking it down. 160 to 180, 180 to 200, 200 to 240. Then the last one, 240 to 300. So frequency densities, FD. These are the frequency densities. 0.2. Take it down from the graph very carefully. This is 1.1, 1.8. This is 1.8. 200 to 240 is 1.6, and 240 to 300, which is 0.5. Next, we don't want the frequency density, but we need the frequency. So we know how to calculate the frequency. So frequency F is equal to FD into class width. So 0.2 into 40, which is 8. 1.1 into 20, which is 22. 1.8 into again at 20, which is 36. 1.6 into 40, class width is 40, that is 64. 0.5 into 60, which is 30. Then we need the mid values. Let me call the mid values as xi. How to get the mid value? 120 plus 160 by 2, which is equal to 140. 160 plus 180 by 2 is 170. 180 plus 200 by 2, that is 190. 200 plus 240 by 2, which is 220. And the last one, 240 plus 300 by 2, which is 270. We got the xi also. Fi, summation Fi is equal to sum of all this. This is equal to, we already know this actually, this has been given in the question. This is 160. Now next thing is Fi xi. Fi into xi, multiply the corresponding Fi and xi. 1120, then 22 into 170, 3740, 36 into 190, 6840, 220 into 64 gives me a big number. Okay, 14,080. 270 into 30 gives me 8,100. Yes, sum of all these is equal to 338800. So mean is equal to sigma Fi xi by sigma Fi, which is equal to 33880 divided by 160, which is equal to 211.75. So this is the answer. So 211.75 kilometer per hour is the mean speed